Look at this. Pascal triangle explained. In this class and in the series of videos that will follow this class, we will be looking at Pascal triangle. Okay? You will agree with me that to solve this, you will simply say this is equal to 1 because anything raised to the power of 0 is 1. No issue. You will also agree with me that if we do this, it's still the same thing because anything raised to the power of 1 is the same thing. Now, if you agree with this, you will write this in two places. Then you expand the bracket. How do you expand the bracket? This multiplied by this. The first one multiplied by this will give you s raised to the power 2. This multiplied by this will give you plus sy. This multiplied by this, the same thing, sy. This multiplied by this is plus y squared. Normal expansion. That is s squared plus how many of these? There are 2 in numbers. That is 2sy plus y squared. This is still good. What if you are now given s plus y raised to the power of 10? It means you are meant to write this in 10 places. I start solving. What if it is s raised to power, say 1,000? 1,000. How many are you going to write? You will sleep here. So Mr. Pascal is saying, why are you wasting your time solving this? All you have to do is to understand the working of this expression. So Pascal came up with a very important triangle. This triangle is used to get the coefficient of what? Of these terms. Remember, this is s raised to the power of 2. The coefficient is what is before this value. That is 1. 1 is here, but we don't write it, okay? Here, the coefficient of this is 2. Here, the coefficient of this is 1. That number that is before the term, because this is a term, this is a term, this is a term, this is a term. The value before the term is called the coefficient of the term. So Mr. Pascal is saying, why are you wasting your time? Let me give you a secret. We asked Pascal, what is the secret? He said, I will show you. Let's see. So Pascal is saying, simply write down 1, 1, 1. 1, this plus this is 2. Then 1. Okay? Say continue. 1, this plus this, 3. This plus this, 3. 1. Say continue. 1. Okay? This plus this is 4. This plus this is 6. This plus this is 4. Then you put 1. He said you can still continue the same process as many as you want. This plus this is 5. This plus this is 10. This plus this is 10. This plus this is 5. Then 1. You can continue this process. As you can see, it's now a triangle. That's why we call it the Pascal triangle. What is this saying? It's simply saying whenever you have something like this, s plus y raised to the power of 0, you agree with me, this will give us 1. The only value, 1, the first one. For instance, you are given s plus y raised to the power of 1. What is that? It's s plus 1. What is this coefficient here? Is 1. What coefficient is here? Is 1. We know ones are there because we don't put them. They are there, okay? They are there, but we don't need to put them. So as you can see, this one now is 1, 1. Let's continue. He said if you have something like this, the one we did before, you already know it's like this, 2sy plus y squared. We have done this. What is this coefficient? 1 is here, 1 is here, and this is 2. As you can see, 1, 2, 1. 1, 2, 1. Continue like this. If you put 3, the same thing. Now, s plus y raised to the power of 3. Pascal is saying, why wasting your time? What we are going to do now, this one is like, it's beyond me. I don't know what to do. Okay? So what I will do now, I will use the Pascal's triangle, because 3 is here, I know I will be targeting after 1, the next number is 3. So that is for any t raised to power 3. Any t raised to power 5 is after 1, I have 5. This line is for that. Any t raised to power 4, this line is for that, and so on and so forth. Because I know this, I will simply write down the coefficient by saying 1, 3, 3, 1. I write down the coefficient, okay? I'll give you the secret now. What do I need to do again? I put SY, 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 SY. What are we doing now? Let me expand this because of the space. Let me zoom in. That is to say, 1 SY plus 3 SY plus 3 SY plus 1 SY. Okay? You understand where we are coming from? We are coming from this 1, 3, 3, 1. Okay? Let me continue. I don't want to crack my brain. I will just follow this method. The next thing you need to do now, what is this value? It's 3, right? I will start with 3 here. I say 3 for S. I will continue to reduce the 3 now for X. 3, 2, 1, 0. Okay? Now, I will come to Y. I start with 0, 0. Then I increase it. 1, 2, 3. Do you understand it? First of all, I put all the coefficients. 1, 3, 3, 1. Then I say SY, 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 SY. Okay? So, as you can see, for X now, I put this 3. Then for the next S, I reduce it by 1. The next S, I reduce it by 1. Then 0. For Y, I start from 0. I increase it. One is decreasing. The other one is increasing. Okay? So, therefore, you agree with me that this is 1 X raised to power 3. Because this Y raised to power 0 is still 1. Okay? Then I have this 3 S squared Y. Because Y raised to power 1 is Y. Plus, this is 3S Y raised to power 2. This one you are seeing here is still 1. That is 1 Y raised to power 3. Okay? 1 Y raised to power 3. So, now I can finish it by saying S raised to power 3, 3S squared Y plus 3S Y squared plus Y raised to power 3. This is the calculation. Okay? You will say, why did you do this one like that? I can still do it like that. By simply come to say S plus Y raised to the power of 2, 1, 1, 1, 1, 2, 1. I will simply put 1, 2, 1. This is SY, SY, SY. Okay? Then I put plus, plus, because there's plus here. Because of this plus, I put plus, plus. Okay? Then I will start from X. The guy on this left-hand side, I start with it. I will use 2 to start. That is 2, 1, 0. Decrease. Then I start from 0, 0, 1, 2. Okay? Equals to, that is 1 S raised to power 2. This is 1, right? No need to put it. 2S Y. Because anything raised to power 1 is the same thing. 1 Y raised to power 2. Okay? Because this is raised to power 0. This is 2. In conclusion, you agree with me, we're going to have this. You see? So, what I'm having here is what I had here before, because I already know the working of this one, because it's simple. So, if you are given something like raised to the power of 10 now, for instance, something like this, raised to the power of 10, you can use Pascal triangle to get the coefficient. Then you use the method of increase and reduction for the power to get the necessary information. Okay? This is just the first class. Let's go straight now and look at more examples on Pascal triangle. Okay?